What are we saying? What is the minimum value when you say set of real numbers? So, what are we saying? You guys, we don't know the minimum value of a real number. What's the smallest real number? So we said negative infinity. So when they tell you the universal set is a set of real numbers, it's basically from negative infinity up to positive infinity. So for the infinity, you guys, we can't use that kind of a bracket, because infinity is not a number. It's just trying to tell us to say, okay, it's somewhere there. Okay. So you can't say, no, infinity is part of a solution set. Infinity is not a number. Okay. So, but basically what you have to understand is the minimum value when you have a set of real numbers, basically negative infinity. So that is negative infinity that we have. Then what is the maximum value before set A begins? The maximum value is what? It's at negative 2, right? So now, the brackets that are going to put around the negative infinity and the negative 2 are going to be determined by the fact of whether it's a member or not. So to start with, the negative infinity, it's always never going to be part of a set, because it's not a number. Then for negative 2, you look at the part there. Is it shaded or it's not shaded? So you see that in this case we shaded it, meaning that negative 2 is basically part of what? It's basically part of the complement. So we'll say union. Okay. So this union is kind of connecting the bridge, because there's a bridge or there's a gap in between here. Why is there a gap? There is a gap between that because that is where set A is. So set A is not part of the complement. So then this other side, the minimum value that we have is a 4 all the way up to positive infinity. So the first question is 4 part of the complement? By looking at that part, is it shaded or it's not shaded? So what kind of brackets are we going to have? Okay, so use a curved one. Then for infinity, is it part of a set or it's not part of a set? Okay, so it will never be part of a set. Okay, so this is the way this is when you've used the number line. So I also made the point to say it's also possible for you to find the set, especially in a case where it is not a requirement for you to show on the number line. There are some questions like that where they basically don't want you to use the number line. They just want you to find the complement. So it's also possible to find the answer like that. So how do you do it? So the way you can do it smartly and faster, you can say, okay, what's the minimum value that I have? Remember, the universal set in this case is a set of real numbers. So I know my set A is moving from negative 2 to 4. So what I'll say is, okay, basically my complement of A is basically going to start from the negative 2 and 4 itself. So negative 2 and the 4. Then I'll put a union in between there. So I'll ask like this, where your A is moving from this point, maybe to that point, let's say negative 2 and 2. Then for your B, maybe it's maybe starting from this point. There are even cases where you're going to have something like this. So let's say this is our A. Do you know that there are cases where your set is like that? Then your B is here. So then this part is shaded. Then that part is not shaded. Let's say that part is shaded. How do you get to find the union of the set? How can you sketch it? what would be the summary of the set? So even this one is easier because I think it's connected already. Like there's no gap. Like it's moving from this point all the way up to that point, right? So your A union B in this case is only moving from, so the minimum value there, let's say, is maybe negative 10. So say negative 10 all the way up to maybe 10 there. That is already our union. Okay. So now it becomes a tricky when maybe there's a gap there. Let's say there's a gap. So if there's a gap, this is the case now where you get to use a union to connect the two sides. So you use that point and this point, then you put a union in between, then you start from this minimum value all the way up to that point. I think you've now understood why, in a case of this question, for the part where we are talking about maybe the complement of C, we talked about a union in between. But you've seen that for A union B, there's nothing like a union in between. All we are saying is the minimum value that we have is negative 4 all the way up to 8, where they are not part of the set. That is our A union B. So there are some cases where it demands you to work with a union to connect two different parts, and also a case where it's just continuous. I hope we were able to see the difference there. Are we together?
Yes.
Okay. So we've answered A union B. There are no questions, right?
Yes, no question.
If you to say like A union B is satisfied.
Yeah, okay, you are right, but I don't want to make that point. Yeah, because you are going to think the same way next time. So, but I'm just trying to say, it's not basically not because B is bigger or something, but okay, yes, because what I'm trying to say is,
Because
okay, let's say something like this, right? Let's say that is where our B is ending, then our A is ending up to that point. The answer would still be the same. So what we are trying to look at, we are looking at the minimum value. Is it continuous? Yes, it is continuous all the way up to that point. So our answer would still be that. So what I'm trying to say, it's not that because B is that, that's why it is becoming a solution. No. We are looking at the minimum value and the highest value. So it basically turns out to be just B, in short. It's by coincidence, not that it will always be that way. Yeah. Have we followed? So let me just do two more examples, then we'll end for tonight. So what I want you guys is, I want you to be exposed to practice questions. Practice the questions. Don't just think you've understood, you wait for the next class just like that, you're wasting your time. So I can start with B minus C. I think let me just go to this one because this one will give like a summary of everything. I can even start with that one. A intersection B complement. So I said, for the sake of the studying sets, whenever they give you something in brackets, basically start with what's in the brackets. So if I start with my set A is from which point to which point? From negative 2 upwards, up to 2. Negative 2, I want to use a different color. Okay, from negative 2 up to 2. That is for set A. Are we shading at the end or not? Then for our B, it's moving from -4. But this question was not well planned, because it's making people misunderstand some of the concepts. Okay, so we are from -4 up to 8. So now if you ask for the intersection, what are they looking at? They are looking for the region that is common, right? So basically, which region is part of both A and B? So you shade, it's this region. This region is part of both A and B. Are we together? So that is our intersection. So the minimum value that we have for our intersection is -2, and the highest value is 2. So now the question is, the brackets that I'm going to use are going to be determined by the shorter one. So you'll say, okay, if you ask yourself a question, is -2 part of both A and B? So it's part of A, it's also part of B, because it is between -4 and 8. So use this bracket. So in short, you just determine by the shorter one. So that is what you have as your A intersection B. That's a region that is part of both A and B in this question. Are we together? So now we have our A intersection B. So let me remove everything else. That was we've not answered the question because that was just guiding us. So what we are saying is our intersection is moving from -2 to 2. So this is our intersection set. A intersection B. So now if they ask you for the complement, what do they mean? They're asking for the region outside that. But within what? But within the universal set, right? So it will be from this point all the way up to -5, and from this point all the way up to what? Up to 10. So is -5 part of the universal? It is. Even 10 is part of the universal. But these parts are not going to be shaded because -2 and 2 are part of the intersection, so they will not be shaded. So I believe we are able to present that, right? Are there any challenges when it comes to presenting that in terms of the interval notation? Any questions? So the minimum value that we have is -5 all the way up to -2 union. Then the upper part, 2 is not part as well, all the way up to what? All the way up to 10. Are we clear there? Have we followed? Okay.
No, sir. I'm behind.
Where have you not understood? Where have you not understood, madam? Our hour is coming to an end.
On the part where you're getting the coordinates for answers, sir, please, I'm asking, sir.
But again, you said you understood. Again, you've not understood. Okay, inbox me after a class because you've been giving the same complaint.
Alright,
Did you watch a video that I made on the same?
no.
That's a problem. Okay, so I think let me answer one more question. Then we'll continue next time. So relatively, I'm not supposed to be this slow, but because you guys did it hard to understand this, I was a bit. That's why I was slow. Okay. So I'll answer this one. So A intersection B minus C. A intersection B minus C. So that's what we have as our question. So basically, I've always been emphasizing to say, start with what's in the brackets. So we said B minus C is basically the same as what? Who can remember? What do you say?
B intersection C complement.
Okay, thank you very much. So B intersection C complement. So now the question is, so to avoid the sketching at times, try to avoid the sketching. So sketch only the final solution there. Let me try to show you the other way of approaching this question. So you have your B there. What is your B? Your B is moving from -4 up to 8. So what is your complement of C? So your C in this case, what you have is what? Is from 0 to 5. Do we agree? Do we agree?
Yes.
So for our C complement, what is the minimum value from the inverse set? It's from -5. All the way up to what? So it will end at this point 0. So I'll use an opposite bracket. Union. Then I'll show that on top. Then the minimum value that we have is a 5. So I'll use an opposite bracket, not that one. Because this one tells you that 5 is part of a set, so it will not be part of a complement. Then the maximum value that we have is a 10. So what is our C complement? Questions? Excuse me. If you want, you can sketch. It's up to you, but I'm trying to give you the other approach that you can work with to save on time. Are we together? Okay. So we're on good. So we found our C complements now. So our C complement that we have is basically from -5 all the way up to 10, then union from 5 to 10. So we're trying to find the intersection between these guys. So to avoid, I wouldn't want to confuse you, so I'll just sketch so that you get to see what's going to happen. So what we have is, that's our number line. What are we saying? We are saying that for our C complement, how is it moving? It's moving from -5 all the way up to 10. How is that possible?
No, sir, all the way up to 0.
Okay, so that's supposed to be a 0. Okay. Yes, all the way up to 0. Thank you. So we have -5 there and our 10 there. So what is our inverse set? So then we have our C complement, which is starting from -5 all the way up to 0. Okay. So are we shading? You look at this part. So we are shading. -5 is part of C complements and there's 0 as well. Then the other part is moving from 5 all the way up to 10. 5 is not part, 10 is part, so shade 10. So this is what we've represented there, guys, is what? Is C complement, right? So now let's show our B. Our B is moving from what? Our B is moving from negative what? From -4 up to what? -4 up to 8. Do we agree?
8.
Okay. So from -4 up to 8. So where are we shading and where are we not shading? We are not shading anywhere, right? Because if you look at B, look at the brackets that are there. So therefore, our B minus C is going to be what? So we are looking for the intersection of the B with the C complement. So let's shade the region that is common. So it's this region, this part. Let me use a different color so that we clearly see that. So this color is common. Oh, this point is common. Even that region is also common. Are we together? So to start with, what's the minimum value at this point? It's -4, right? So are we shading or not shading? -4. So we have -4. Is it part of the intersection or it's not part of the intersection? If you're able to answer that, then you've understood everything that we've discussed in this lesson.
Part of the intersection.
Is -4 part of B? So the fact that
It's not.
that end is not shaded, -4 is not part of the intersection. So use that bracket. Then all the way up to 0. So what is going to determine again is this point. Is it shaded or it's not shaded? It is shaded, right? So union. Then the other part. What is going to determine is this region which is there. Is it shaded or not shaded?
Not sure.
And what value is there? 5. Okay. Up to what? This point. 8. Is it shaded? Is that point shaded? It's not.
Okay.
So that is our B minus C. Do we all agree? Do we all agree? If we understood.
Yes.
Okay. So we found what is in the brackets. Now we need to find the intersection between the B minus C and what? And the A, right? So I'll draw the number line again. So our B minus C is moving from -4 to 0, then from 5 to 8. Okay. Excuse me. So where are we shading? Where are we not shading? We're only shading at 0. That's the only point where we are shading. That is curved, that is curved, curved. So what we've shown there is B minus C. Now we need to show A as well. So A is moving from -2 up to what? Excuse me. Up to 2. So what is region there? I hope that is my approximation is right. -2 is between -4 and 0, right? Okay. I just hope I'm right. Then I also hope 2 is between 0 and 5. So we're trying to find the intersection. So only one region is intersecting. Only this part. So what do you think is the intersection there? From -2 to what?
To 0.
Are they part and parcel? Are-
Yes. They are.
okay, so the regions are shaded at the end. So they are. So this is our solution to the question that we had at hand. Okay. Are there any questions? Are there any questions?
So are you saying it's a solution for